So let us see some basics of thermodynamics. Now here we will consider the units of pressure. 1 Newton per meter square is known as 1 Pascal. 1 kilonewton per meter square is known as 1 kilopascal. 1 bar is 10 raised to 5 Newton per meter square. Now the relation between bar and kilopascal is that now this 10 raised to 5 we can convert into 10 raised to 2 into 10 raised to 3, that is equal to 10 raised to 5, and 10 raised to 3 is nothing but kilo. So we can say that in order to convert bar into kilopascal we have to take into consideration 10 raised to 2 as a multiplication factor. For example, if it is a 20 bar, then it will be 20 into 10 raised to 2 kilonewton per meter square. To convert kilopascal into bar, we have to divide by 100. So 600 kilopascal, if you want to convert it into bar, then divide it by 100. That will be the reverse procedure that just now we have seen. So to convert bar into kilopascal, we have to multiply by 100. And if you want to convert kilopascal into bar, then you have to divide by 100. So 600 kPa will be 6 bar, or 6 bar will be equal to 600 kPa. You have to multiply this 6 with 10 raised to 2, that is 100. To convert bar into kPa, we have to multiply by 10 raised to 2. So 6 bar is 6 into 10 raised to 2, that is 600 kPa. That is just now we have seen. Now the most important part is the 1 MPa. Mega means 10 raised to 6 Pascal. Now 10 raised to 6 can be written as 10 into 10 raised to 5 Pascal. Now 10 raised to 5 Pascal is nothing but what it is, bar. So this term is equal to bar. So we can say that MPa to bar conversion, you have to use the multiplication factor as 10. So as you have seen in the earlier case, 1 bar is 10 raised to 5 Newton per meter square. So the same concept we have used over here. So in place of this 10 raised to 5, we have substituted bar. 10 raised to 5 Pascal, that has been substituted as bar because 1 bar is 10 raised to 5 Pascal. So to convert MPa into bar, we have to multiply MPa by 10. For example, if it is 30 MPa, then 30 into 10, it will be 300 bar. Now atmospheric pressure. 1 atmospheric is 1.01325 bar. Now this bar is nothing but 10 raised to 5 Pascal. So it is as good as 1.01325 into 10 raised to 5 Pascal. Similarly, if you want to express in terms of kilopascal, it will be 1.01325 into 100 because bar is equal 1 bar is equal to 100 kilopascal. Here 1 bar is equal to 10 raised to 5 Pascal that we have written. So 1.01325 multiplied by 100 is 101.325 kilopascal. Another way by which atmospheric pressure can be expressed is 1 atmosphere is 10.33 meter of water. It is also equal to 1.033 kg per centimeter square. And as we know, famous unit is 1 atmosphere is 760 mm of Hg, or to convert mm into cm, we have to divide this by 10, so 76 centimeter of Hg. Now work, heat and energy, they are having the units of joule. So 1 joule is 1 Newton meter, 1 kilojoule is 1 kilonewton meter, 1 kilocalorie is 4.184 kilojoule. Now 1 kilowatt hour is 3600 kilojoule. For example, if the electric unit consumption per day is 20 kilowatt hour, then the consumption is 20 into 3600 kilojoule, that is 72,000 kilojoule. So kilowatt hour can be converted to kilojoule by multiplying by 3600. Important part is the units of power. 1 watt is 1 joule per second. Joule is Newton meter, so it is as good as Newton meter per second. Similarly, 1 kilowatt is 1 kilojoule per second. So kilojoule, so kilo as it is, in place of joule we have to substitute Newton meter. So it is 1 kilonewton meter per second. 1 kilowatt is 1000 watt. For example, 1 HP is 730.5 watt or 0.7355 kilowatt. For example, if you are having a motor of 2 HP, then we can say that motor power will be equal to 2 into 0.7355 kilowatt. So we have converted HP into kilowatt. So value is 1.471 kilowatt. Now temperatures can be converted like this. Kelvin will be equal to degree centigrade plus 273. Suppose it is 30 degree centigrade. Then it is 30 plus 273, that will be 303 Kelvin. If you want to convert centigrade into Fahrenheit or Fahrenheit into centigrade, then you can use this particular formula. Now we have to remember certain standard values before we learn thermodynamics. So specific heat at constant pressure is 1.005 kilojoule per kg Kelvin. We are talking about air. CV, that is specific heat at constant volume, 0.718 kilojoule per kg Kelvin. Characteristic gas constant is 0.287 kilojoule per kg Kelvin and gamma is 1.4. We'll be seeing this part in detail in our theory lecture. For water, it is 4.187, Cp is 4.187 kilojoule per kg Kelvin. Mass density is 1000 kg per meter cube. Specific weight or weight density is 9810 Newton per meter cube. For ice, it is Cp is 2.09 kilojoule per kg Kelvin and latent heat of fusion of ice is 335 kilojoule per kg. For superheat testing, the value of Cp varies largely between 2 to 2.8 kilojoule per kg Kelvin. Now, unit of refrigeration. 1 ton of refrigeration, TR stands for 1 ton of refrigeration, that is 210 kilojoule per minute. It means that in 1 minute, the heat that is abstracted from the hot substances which are kept inside the refrigerator is 210 kilojoule. Divide this by 60, it will be 3.517 kilojoule per second. It means that in 1 second, this much amount of heat is removed from the substances which are kept inside the fridge or refrigerator. For example, if the refrigeration plant capacity is 20 TR, then multiply this 20 by 3.517, so that the value is 70.34 kilojoule per second. Practically, it means that in 1 second, you can the heat abstracted is 70.34 kilojoule. Universal gas constant is 8314 joule per kg mole Kelvin or 8.314 kilojoule per kg mole Kelvin. So here this meaning is written that we have already seen that 70.34 kilojoule per second means in 1 second 70.34 kilojoule of heat is abstracted from the working substances which are kept inside the fridge